Hello everyone, welcome to my YouTube channel. And today I was going to go over the math behind AI. And now this is a very vague concept, but all in all, what I want to demonstrate with this video is what an AI really is. Because chances are, a lot of us think of an AI as a huge um black box is what we usually call it, where we don't know what's happening. It just goes in and it comes out. And over here, I want to get a high level understanding, which is what we call like an understanding of the core concepts of what really is an AI and what it's actually doing under the hood. So now when we think of AI, we usually think of something like ChatGPT or the algorithm that's recommending you videos on YouTube. And I'm going to start with an example with ChatGPT. So firstly, what is an AI? An AI is a function. Yeah, just that f of x that you learned in school. You give 1 to the function, well, it outputs something. Maybe it outputs 3.5. Maybe you give 2 to the function. Maybe now it outputs 5. The thing is, like, you don't really know what the function is yet. I'll explain more about the actual function soon enough. But, uh, for right now, what you need to understand is an AI is just a function. However, the important part about this function is that it's a really, really complicated function. Otherwise, it wouldn't be able to actually properly demonstrate what an AI is supposed to do. Even simple AIs are very complicated functions. Let's think about a very complex AI for now. ChatGPT, or just, you know what, GPT, whatever. So say you said hello to the thing, right? Now, before it goes into the function, it has to be turned into an array of numbers. It has to be numbers somehow. That's all that matters. I'll go into detail about how transformers work in maybe another video, but I will say that it turns this hello into numbers, well, and then it passes them, so it just transforms them, and it goes into functions, and into the function, which is the AI. This function is what does all the work. It then transforms it back into a readable language for humans, like, we are, uh, in this case, we put it in English. It's probably going to output in English as well. And so it transforms this back into English from the numbers that we input in, and it gives an output. Like it might say like, "Hi, what can I do for you today?" So yes, the function that really does all this thinking and outputting is really complicated. But now that you know what an AI is, it's literally just a function. I'm going to talk a little bit more about how this function works. Um, oh no, I can keep that. Think of this function for now as a function that has a bunch of knobs. So let's say we have um let's say the function is um a plus b x plus cd plus a. So say this is the function. We have four variables, a, b, c, and d. And we can change this to be whatever we want, right? And so what an AI will do while it's training is we will have these little knobs, which we're going to call the variables a, b, c, and d. Or maybe just a slider. And so maybe a is over here, perhaps b is over here, c could be over here, d could be over here. So these are maybe some sliders that represent a, b, c, and d. So now what? Well, what an AI does is it tries and finds where to put these numbers. So it moves the slider around and tries to find the numbers that make this function do what we want it to do. Maybe we just want this function to just double the number, right? That's a simple function. So we might have this them try and find the AI, try and find the A, B, C, and D to try and double the number in this function. Now you might think, isn't doubling a number quite a simple function? But this is just an example. These functions in modern AIs, we have thousands, and in stuff like ChatGPT and all, they have trillions of different variables. And you can think of those as little sliders that can change around and do different things. And so what happens is, let's think of something simple. We have an image of 9. So let's see what the think about like the AI is going to do to say, okay, now this is 9. It's probably going to split them up into pixels. Say it splits them up into 28 by 28 pixels. So it splits this part up into 28 pixels and this part also into 28 pixels. So in total we will have 784 pixels of information, right? And so once we have all those pixels of information, we can feed them all in. Now, it's not the same as the function we might have seen here, right? No, sorry, the function we might have seen here, where we just take in one number and it gives out one number, right? In this case, the function takes in 784 different numbers, right? 784 different numbers, and it goes through a function. I remember when I talked about this function. This function, because it's doing something like number classification, has to be really complicated. Usually we would have around 3,000, well no, around 10,000 different sliders. We call these things called the parameters, or params for short. So that's how many of these numbers we can modify to get the answers we want. And then it comes out into a classification and it says, okay, it's 9. So we take 784 different numbers in, and yeah, it gives an output of 9. This is the main high level overview of an AI. Now I'm going to go into a simpler, no, not simpler, but a more low level overview of it. Alright, so now I will be talking more on a little bit lower level, so more on the actual math of AIs. And for this section, it's best to have a lot of knowledge on linear algebra, or at least some, because this will be like the main section of the math in AI. So since I'll be talking mostly about the math, it's best to have enough knowledge of linear algebra. 3 Blue 1 Brown has an amazing series on this. I will link it in the description. So let's just get into this right now. So now most AIs, or pretty much all of them, they don't just take in one number and output one number. They take in multiple numbers and output multiple numbers. So how do we work with multiple numbers? Well, here's how it's usually worked with. We build something known as a vector. Basically, say we want to put in 2, 3, and 4 in. And then this goes into a function. And the function does a bunch of stuff. And maybe it now outputs 7, 9. So this is, well, professionally what we do when you're trying to make an AI. It takes in a vector of inputs and it gives out a vector of outputs. Now this is slightly changed when you get into stuff like ChatGPT, but those are much higher level. Those are transformers, so it's much more complicated. But for now, I'm going to for this section I'm going to assume that you know a little bit about matrix multiplication and all. So now I'm going to break up this function. We have been treating this function the whole time as just a little black box, which we know kind of what it does. It is the AI, but we've never actually explained what is happening inside it. And now what's happening inside this is vague. It very much varies. There are CNNs, MLPs, stands for multi-layer perceptrons, CNNs, convolutional neural networks, transformers, well, yeah, that doesn't really stand for anything. It, but yeah, there are so many different things that an AI can be doing. So, well, what's going to be happening inside this one? Well, we're going to be choosing the beginning for like most uh ideas of AIs, and almost all of them really start here at MLPs. Now I'm going to break up MLPs because MLPs is also actually a another idea for neural networks. So I'm going to break this up and I'm going to specifically talk about dense layers or linear layers. Okay, so let's see what this f of x really is. Let's break it down. So firstly we break this down into multiple layers. That is what it means to be a multi-layer perceptron. It has multiple layers. So it first goes through a linear layer, then it goes through an activation function. So and I'll go into detail about this obviously. And then it goes through another linear layer and another activation function, and then goes into an output. So yeah, this is just a breakdown of what a simple multi-layer perceptron can be doing under the hood. So let's see what an example of like each of these are. A linear layer, what it does is it takes in your input, um, and you apply a matrix multiplication to it, and then get an output. There's actually another way to show this, and I'll explain that soon enough. But imagine a linear layer like this. We have the input 2, 3, 4, and we're going to imagine these nodes. This is 2, this is 3, this is 4, and we have 2 output nodes. And imagine us making every possible connection we can. This to this, 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 and this. So now we've made quite a lot of connections now, that exactly 6. So now what happens? Well, imagine these 2 output nodes over here to be the output of our linear layer. And imagine that each and every line has something we call a weight. So maybe this line's weight is 2, this line's weight is 3, this line's weight is a -1. Each and every line has a weight. So you know what, let's zoom out and let's actually build a much bigger version of this. 2, 3, 4. And we have the 2 outputs. This will be have a weight of connection, weight of 2. Maybe this is 3. Maybe this is -1. This is -2. And remember, these weights that I'm showing in the middle are actually the parameters of our AI. We change them to whatever we want to get the result that we want. So now let's see how a linear layer does its calculations. Each and every connection has a weight. So this 2 over here, let's go with this 2 over here gets multiplied by this 2 over here and gets over here as a 4. right? And now we have this 3 over here. It gets multiplied by this -1 over here and comes over here as a -3. Hold on, I put that badly. A -3. And say this one, this 4, gets multiplied by this 3 over here, comes in as 12. And so we add all of these up. So 4 plus -3 plus 12 to get our answer 13. So now we know this output is 13. And we do that for the other one as well. So 2 over here, 2 over here, and I'm going to speed this up a little bit, times 3. We get 6. 3 times -2, we get -6. 4 times 1 gives 4. So the output on this node will be 4. This is how a linear layer does its computations. Now for us this seems kind of complicated, maybe, or maybe the concept is simple, but it seems like a lot of work. But for an actual AI, this is actually quite simple, because doing multiplication is not very difficult for a computer. So yeah, this is an example of a simple layer that takes in these inputs, makes every possible connection, and each connection has a weight. And this weight is what we call a learnable parameter that can change. We change this to make it output what we want. So maybe, and oh, also over here we have in each output node there's one extra learnable parameter we call it bias. So it's like the small little number we add. So maybe the bias of this node is 2. Maybe the bias of this node is -1. So that means the final value for this node will be 3. The final value for this node will be 15. So this is the basic idea of how this works. We have 6 weights and 2 biases. The total amount of learnable parameters for this. I will go into learning perhaps in a different video, but this is the core concept of how an AI does its linear layer. Now we need to talk about what an activation function is. So it's possible to just go over here and just ignore the activation function and go straight to the new linear layer. So maybe now that we have the 2 outputs from this, 15 and 3, we get into another linear layer. Maybe this one gets us only 2, and we make every possible connection, and each connection has a weight, and each connection has a bias. Maybe this one's plus, maybe this one is minus, maybe this one's also plus, who knows. But there's a small problem with this. This is completely redundant. Here's the thing. All these linear layers can do is just linear multiplication. So just like mx plus b. This means that they can never actually learn anything complicated. Like they cannot learn stuff like trying to classify a number, because, well, it's all just linear multiplications. We need something that throws it out of this linear, and that is what we call an activation function. An activation function is pretty simple. It just takes every single number. So let's say we have 15 and 3. It just takes every single number and it plugs it into some function. A very commonly used activation function nowadays is just ReLU. So what this does is it takes in some number and it takes the maximum of 0. Okay, hold on. It takes the maximum of 0 and that number. So basically, if the number is -2, it runs up to 0. If the number is +2, it just keeps it as 2. And so in this way, you will never have any negative outputs. And you might think, why is that a problem? And the thing is, it's not a problem. But if we don't have something like ReLU, what's going to happen is that this AI is only going to do anything that is linear. So if something is not linear, like it's hard to visualize what linear even means with some complicated AIs. So let's say the AI's job is to try and model a quadratic, right? So it's the function is just f of x equals x squared. But how are we going to make f of x to be x squared if all it's ever doing is linear multiplications? Which is why we need something to really spice it up, to really change it, so that it's no longer just linear layers. Now ReLU is very fast, and it works really well. And the reason why ReLU works is actually pretty complicated. You might think, how does this make it non-linear? And what it really does is it turns this into this, which and I'm going to just be on a high level here of what ReLU does. If the had no activation function, and it's very important to understand why activation functions exist. If it had no activation function, it would probably try and do something like this, because that's the closest it can get, right? With no activation function, it can only ever be linear. But with ReLU, we can cause a bend like this. So now, with say we have multiple ReLUs, we can do something like this, 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 this. And now it looks very different. Now we can actually see how our AI is bending the line. So this is like the main reason why we have activation functions. Otherwise, everything will be linear. And it is quite simple to understand how trying to classify a number is not at all a linear task. It is anything but linear. So this is why we have these activation functions. So what happens? It makes every number, it makes it go through a linear layer, makes it go through an activation function, makes it go through a linear layer, then an activation function, until we are satisfied. And so this is how we build our function. Now there are many other things we can add to our function, like CNNs, and maybe I'll go into detail about that. But this is mainly what is happening inside as a function. It's just split up into multiple layers, and each layer does something different and has different learnable parameters. And eventually we can change these learnable parameters to get what we really want. Thanks for watching my video and have a great day.